Okay, welcome back. We are working on examples 4 and 5, still trying to graph rational functions. Same sort of instructions for this, and they've done part of example 4 for us. So here is the original form. Here is the factored form. Again, when we think about end behavior, we're going to take the highest degree there, which is x squared. The smallest or highest degree here, which is x. We divide the two. We're left with just an x. And we know what, that's our end behavior model. We know what that graph does. This is saying on the right side, the y values are getting bigger, so it's increasing or it's getting higher. And on the left side, it's going to be going down. Okay, so this is what I want you to take away. There is no horizontal asymptote. Now, over here, you can actually just cross this off. This says that there's a slant asymptote, and we are not going to get into that. But we can be very specific about what the end behavior is going to look like. I'm just not going to hold you accountable for that. So we're just going to worry about this kind of notation. Okay, notice there's no holes for this one. Okay, so if we look at the denominator to make that equal 0, we're going to be looking at, this should say -1. So do make sure you make that change. That was a typo there. But to make the denominator equal 0, this would be a -1. Okay, and we need to do the rest. So we're going to find x-intercepts and y-intercepts and then try to graph without a calculator. So go ahead and I'm going to go back to taking some notes here. But you'll have to refer back to what you're seeing on the screen there, okay? Okay, so how do we find x-intercepts? We're going to take, oops. We have to take the numerator, which is x plus 4, and x plus 2. We're going to set it equal to 0, and that's going to happen when x equals -4 or -2. Just squeeze it in there. Okay. For your y-intercepts, that's where we plug a 0 into the x's of the original function. So we're going to find g of 0. Okay, and we've done this enough now. Just realize all the things that have an x, they're going to go away. We're going to be left with 8 over 1, or just 8. Okay, now from that, we need to come up with our graph, all that info. Okay, it's going to be easier, in some ways easier than you think. Okay, so again, you go ahead and you make the following kind of marks on your thing. If you want to pause the video and give it a shot, go for it. Here's what we know. We know that well, first of all, we know end behavior, and this may not match up exactly with what I draw in the end, but I know it's got to go up on the right side and down on the left side. I know that. Okay. In part B, I know that at -1, there is a vertical asymptote. So maybe something kind of like this. Okay, I know that at -2 and at -4, there's x-intercepts. And I know the y-intercept is what? It's way up here at 8. Okay? So we have to put all of this together and try to make a graph. Okay? So again, I'm going to start on the left side, and this will take some practice. You're not going to quite get used to this until you just try some. So you're going to have lots of opportunities over the next little while to try some. But if I start on the left side, I have to get to this x-intercept. I know that. The multiplicity was 1. It's going to go through. So it's going to go through. And I don't really know how high it's going to go, and I don't necessarily care how much you tell me or how high you think it goes. But at some point, it has to go through the other x-intercept, and that also had a multiplicity of 1. So it's got to go through there as well, and now it really can't go back up because there's no other x-intercepts. The only logical idea is for it to go down like that. And it's gradually moving to the right. I mean, I've made it look kind of vertical there, but it's going to gradually keep going to the right. Okay, now the right side is really interesting. In the end, I'm just going to kind of cross that part out because I don't like where I put it. But what I know is it has to be going up, and it has to go through this point. And once I go through that point, I really can't go down anymore because, well, I could go down a little bit more, I suppose, or I could have gone down even more than had it kind of coming back up at this point. But what I know is it can't go through the x-intercept right around here because there are none. We found the two and they're on the other side of that vertical asymptote. So the only option it can really do is it kind of hits that and eventually it's going to start climbing again over on that side. I don't know where the minimum is here. I guess that's what I'm trying to say. I don't know where exactly that minimum is. I just know it's somewhere. There is going to be a minimum, and I don't necessarily care where it is. I'm just looking for the general sort of graph that this would produce. So go ahead and type this into your calculator if you don't trust me. Just make sure your numerator is in a set of parentheses and your denominator is in a set of parentheses, but this is, in the end, what you would see. So I think that's good for that one. I don't think I'm going to cover anything else there. But there's some things you have to really think about for that particular graph. All right, I'm going to delete this picture. Okay. And we'll go back to the PDF a second. Okay, example 5. Now we're doing everything on our own. So now we have to show a lot more work. So let's just kind of go through the steps. This might be good for you guys just to see how I would typically show some of this work. I think labeling things can be kind of important, and I don't know if I did a great job of that. I guess I kind of went with A, B, C, and D. I can do it that way, but what I would really like to get in the habit of, especially for assessments and things like that, is kind of label what I'm finding. So if I look at N behavior, I can even put M for N behavior model. Okay, for this next question, what I should have done first, I'm going to undo some things here. Let's see, can I do that? Yeah, okay. First thing we should do is just kind of write out the equation again. So it's 3x plus 1 over x squared plus 2x minus 3. And while I'm writing this, I'd be interested in knowing what you guys get from this video. I can hear my computer just humming like crazy right now, and I'm afraid it's probably coming through on the video too, but hopefully it will work. So we have it in factored form. That's kind of what I was saying. So I should have maybe walked you through that a little bit, but I think that would be what it is in factored form. And now I can talk about some of these other things. So for N behavior, or N behavior model, I'm going to take the highest degree on the top, which was 3x, and the highest degree on the bottom, which is x squared. That's going to reduce to 3 over x. Okay, so 3 over x, it's like a reciprocal function, and what we know on the left and the right side for that, so the limit as x approaches positive or negative infinity, and this is function k, so k of x, we know that's going to be 0, because that's what 3 over x would do. Okay, we need to find vertical asymptote, so we need to know where does the denominator equal 0. So we're looking for where does x plus 3 times x minus 1 equals 0, and that's going to be at x equals negative 3 or at positive 1. Okay, let me bring that up there a little bit. Okay, we need to look for x-intercepts. Oops, let me switch colors. Red. Okay, where are x-intercepts? Okay, for this one, we're looking at the numerator. Where does 3x plus 1 equals 0? And that's going to be when x equals negative 1/3 if you move the parts around. And then finally, we are looking for the y-intercept. Okay, and that's again what happens when we plug a 0 in. So we're trying to find k of 0. It's going to be the constants, or the last coefficients that go with a degree of 0. Does that make sense? Okay, and that's kind of interesting because that's also going to be negative 1/3. Okay, so now we have to take all of that and try to graph it. And again, this can be kind of tricky. Take some practice. Okay, so first thing I like to do is again that N behavior. So it's right around 0 now. It's approaching 0 more than likely. So this little green arrow here, it could be above or below. We're not quite sure, but we just kind of draw it right around 0. But that's one thing that I know. We found vertical asymptotes. One was at negative 3. Okay, so we'll kind of do that one. I probably should have done that a different color. Oh well. Okay, and the other one was at 1. So I'm not necessarily doing a great job of going to scale. We'll switch the function to red. Okay, so we'll cover this with red here. Okay, we know that there were x-intercepts, or let's see, an x-intercept at -1/3, kind of right there, and also a y-intercept at -1/3, something like that. Okay, and now we need to figure out the graph. Well, one thing I can tell you right now is just looking at the middle part. If I start at that y-intercept, okay, I know it has to somehow connect there. But if I move to the right from that y-intercept, I can't go up again because, again, there's no x-intercept, and I can't just run into that vertical asymptote, so it's going to have to come down like that. And kind of the same thing on the at the x-intercept going to the left. It can't go back down because there's no other x-intercepts for it to go through. It can't run into that vertical asymptote, so it's going to have to come back up there. So I'm just kind of making it look like kind of like a cubic function in there. I don't necessarily care if you are that detailed or not. You can graph it. You're going to see that it probably is. But that's kind of up to you. Okay, so we're kind of stuck on the left and the right sides. And so notice in your instructions that sometimes they say just go ahead and come up with some additional points. So I'm going to, let's see here. Maybe I'll just do this down here a little bit. No, we don't want to do that. We want to do this. Okay. So I'm just going to make almost like a sign chart or maybe a T chart and think a little bit about what's going to go on with this function. Okay. So way on the right side, I need to get to the right side of that vertical asymptote at x equals 1. So I'm just going to say, what happens if I plug in a 2? And I'm going to look at the factored form. So if I were to plug a 2 in for the x's in that factored form, just like we did with the sign chart for polynomials, we're actually going to look at sign charts of rational functions by the end of the week. But if I were to plug in a 2 into the numerator, I would end up with something that's positive. Okay, and if I were to plug in a 2 into the two parts of the denominator, I get positive for the, whoops, sorry, it's supposed to be a positive, undo, 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 okay? I get positive for the first part of the denominator, I also get positive for the second part of the denominator. That tells me overall the number there at x equals 2 is positive, okay? So if I were to go back up, oh, let's see here. What did this do? Did it make me a new chart here? Let's see if I can find. Ooh, it saved it. Okay, learn all kinds of stuff here. Okay, so we just did that the sign chart. We said at 2 it was a positive answer. Okay, so now I know that at 2 I'm somewhere positive. Okay, the green line's at 1, so at 2 I'm just somewhere positive. I don't really care about the number because I'm just getting a sketch. And so now that tells me that there's no x-intercepts. It probably just has to go up like that on the left side. I'm sorry, on the right side. Okay, if you did that on the left side, so let's say that we kind of did that with, I'll just make a new kind of T-chart here. You guys can just kind of add in yours. But if I did that on the left side, maybe thinking about a -4 for x, because that green line is at -3. Well, if I plug a -4 into all those parts, every single chunk is going to be negative. And that means overall, it would be negative, right? If you go through and think about in the denominator, negative times a negative is really positive, and so I'd have a negative number divided by a positive number, that's got to be negative. So on the left side, it's going to be below over here. I know it kind of looks like it's above, but really it would be below, just really close to that x-axis and going down like that. Okay, so that's going to be kind of what that looks like. Again, it takes some practice. There will be a couple tough ones that do your best with, but I think overall a lot of these you'll get good at just by putting some work in and practicing it.